We're learning how we generate power in a nuclear power plant. Whenever you generate power, you're making steam. The steam goes through and turns a turbine, a propeller, a fan blade, and if you've ever done this, you can generate electricity if you have an electric current going through a coil of some sort, and then you spin magnets around it. That generates electricity. It's like your car starter does that. It takes magnets and it spins them around the coil. You have that 12-volt battery in your car. That generates a current, and if you spin magnets around it, that turns it into the however many volts that you need to start your car. This is the same thing, except massive if you were to go to a power plant and see the size of the turbine. So the steam goes up, turns the turbine. The turbine generates electricity. The fan turns, electricity is generated. It's relatively much more complicated than this, but energy gets to your house and something turns on in your house. Okay, nuclear power is no different than when you burn coal or natural gas or anything. It's just that instead of burning something underneath a big vat of water and causing it to boil, instead you immerse uranium fuel rods either into water or into some other substance. There are many different designs. The simplest to understand is called a boiling water reactor. That's what this is. You shoot some neutrons. We've talked about this part. You take some neutrons, you shoot it at the fuel rod. The fuel rod starts to, you have fission that happens inside of the reactor. Uranium is split into, say, barium and krypton. Other neutrons come out, and that starts the chain reaction all over the place. If you have enough uranium-235, which is the fissionable isotope, and that causes, the chain reaction causes an enormous amount of heat to be released, and that causes the water that's in here to boil, to turn into steam. So the water goes from a liquid form to steam, basically. And then it's just, and once you heat the water up, this is a very standard issue electric generating plant, except that everything has to be sealed like crazy, because the water that's moving through here in this particular kind of reactor is highly radioactive, and corrosion products can build up on here. It's like rust, except it'll kill you. It's kind of white, and it's highly radioactive. I don't know if Mr. Leidy's going to be able to come in and talk to you all about his experience as a nuclear power operator in the U.S. Army, but he achieved the distinction of being a nuclear power operator in the Army, and he's actually seen one of these things taken out of a turbine for maintenance, and he has a story to tell about that. I won't say anything else. It's a damn good story. But anyway, everything here has to be very highly sealed. But okay, so the steam comes through. It's still hundreds of degrees. Don't forget, water can only go up to 100 degrees Celsius, 212 degrees Fahrenheit, but steam can be superheated, as is the steam in a nuclear power plant. And so superheated steam goes through, superheated highly radioactive steam goes through, and then, well, as you can see, it's liquid water here again, and that means it gets cooled. And the way it gets cooled is because other pipes bring water from a river, an ocean, or a very big lake. I believe we generate nuclear power on some of the Great Lakes. I could be wrong about that, but I think we do. At any rate, you need a very big source of water, almost a limitless source of water. You know, you can't just use a swimming pool or something, because what happens is the water comes in and it absorbs heat and takes it away. So it goes through in a closed system. This water and this water never touch each other. This is a metal pipe. The heat transfers through a pipe. It's not like an air conditioner, sort of. This is like a condenser. You have cooling water coming through here. It absorbs heat out of this system, which causes the steam to condense into droplets and finally into liquid water again, and the heat is taken away. And which means that this water goes up, I don't know how many degrees, honestly, but the water goes up in temperature between coming in from, say, the Connecticut River, to use the example of Vermont Yankee. Water comes in, heats up as it takes the heat away from the reactor water, and is released warmer. Now, depending on what time of year it is, two things can happen. One, if it's cold weather, the water goes right back into the river without any treatment usually. Much warmer. But it's cold, so it doesn't really hurt anything, I guess. But if it's really warm, I have to kind of mess with my picture here a little bit. If it's warm weather, I'm going to erase this little bit of it. What happens is that the water is diverted instead into cooling towers, which are the iconic shaped things that you've seen. So, in other words, this is what people see when The Simpsons opens up, and when people think of nuclear power, they think of these things that are sort of shaped like this, and people must think that this is where the nuclear power is happening. It's not. This is just called a cooling tower. And what happens is the water is pumped up to the top of these towers in pipes. Still warm, quite warm. And then it sort of cascades down the inside. They release it to slowly roll down the inside and be cooled by the air as it does that, which is why you always see that when you see stuff coming out of the top, that's just steam as part of this cooling process as the water loses that extra heat and then goes back into the system, or then it's released from there, back into the river, lake, ocean, or whatever. So, okay, that's more or less how it works.